Join the movement. Go all electric with Pure Electric.
Hi, my name is Roger. I designed and built a house in Reedy Creek on the Gold Coast in 2005. It's a concrete home, which many people wouldn't argue is a sustainable house, but I'd like to show you my home and show you why I think it's sustainable. The house is located on a hill elevation about 100 meters above sea level, catches a lot of breeze, doesn't have any immediate trees around it to shade the home, so it had a lot of opportunity to put on solar panels and an opportunity to catch the prevailing southeasterly breezes and have them sent through the house. The house is over 3 split levels. It's full concrete construction apart from one additional room that was put on in about 2010. It's concrete cord beser with steel frame, as you can see in the slide. Internal walls are all also concrete with steel frame door surrounds. This photo just shows quite a large amount of concrete that was put into the job, and yes, that does have a high CO2 component, which would be a lot less had we used timber and traditional building methods or more modern sort of building methods. The offset to that is that this house will last for potentially hundreds of years, perhaps needing a new roof because it's a corrugated iron roof at some stage. But the structure itself, potentially can last, many times longer than a conventionally built timber frame home that's clad with plasterboard and fibre cement sheeting and so on the outside. So it should last many times longer, many generations. Even the upper floor is a full suspended concrete deck, and on the upper floor we put the kitchen in order to capture the views that were afforded to this particular site. When I was designing this house, the first thing I thought about was solar orientation. So what you're seeing here is the north face of the house, and you can see there's an awful lot of glass facing north. There is also an eave, a 1.2 meter eave on that north face, and that's to keep the sun out during summer. And obviously in winter, the glass will allow a lot of sun into the house. All of that glass is what's called low E glass, so it has a plastic film, and it's also double pane glass, so that reduces the heat transference through the glass. So basically in autumn and spring we still maintain a fairly level temperature within the house without air conditioning. I think the coldest the house has ever been is about sort of 15 or 16 degrees without heating. And the warmest it's ever been is possibly about 30 degrees inside without the air conditioning. And that's because we have an enormous amount of thermal mass which regulates the temperature of the house. So we tend to use air conditioning in the summer, and that's more for humidity than for cooling. But obviously if we get a number of days in a row that are very hot, then the whole house heats up and we do turn the air conditioner on just for comfort. And fortunately we have so much solar panels on the roof that it literally cost us nothing to run the house. We put solar panels on and the battery in about 2016, and we haven't paid an electricity bill since then. So on the south side of the house we have quite a few windows also, and that's just to allow the flow through of the prevailing southeasterly winds through the house. In 2010 we added a deck to the house and enclosed an additional room that was a balcony. and is now basically a rumpus room. So for the decking boards, we've used these composite boards, which as you can see are hollow. That reduces the amount of material that's actually required. The nice thing about these composite decking boards is that they're basically zero maintenance. The worst thing that happens is they can grow a bit of mold, and you can get the gurney out and clean them off. So they're also good because they don't have nails and so on coming up through the floor, which you could potentially trip on or cut yourself if you had bare feet. So I quite like them. As you can see here, this is actually the deck going on the house, and at this point in time I actually had a little bit more money than when I was building the house originally, so I was able to put the new roof on, and that's the foam sandwich Colorbond type product. It's called Solar Span, I think, from memory. And that meant that we didn't have to do the insulation sarking on the inside of the Colorbond. It's all contained in the roof structure, and it spans a bit further, and it's quite good. The whole deck again is just a massive steel structure that got the decking boards from the previous slide. So with the exception of the crane that came in to help me move all the steel, and the people that helped me move the steel into place, I did this whole room myself, which meant that I wasn't capable of doing the Besser block, concrete cord Besser block, so I decided to do a steel frame enclosure for this room and put on these weatherboard shingle type things, weatherboards, except they're actually plastic and they have a foam inner lining, again for the thermal properties, so that the room doesn't get hot. The window side faces west, so that's actually we put a window there so that we could see out to the west and see out to the street, but otherwise the north and west faces are quite closed in, and it's only the eastern face on the far side of this photo that's got a door opening out onto the deck. So we've, again, every room in this house has flow through air, so this one does also, but it's quite well insulated. The deck afforded us quite a lot more shade during summer months, which is fairly essential in our climate, and gave a little bit more sun protection to the large bifold you can see under the deck there. That bifold obviously opens up fully, and there's another one in the upper deck, which allows us to open up to the environment as much as we can during the, when the climate is suitable. So this is the upstairs deck that basically got partially enclosed. It's got fly screen all around, and it's got a large bifold again, which we can open up and eat out on our deck for breakfast and dinner frequently. The other thing of note is that originally when we built the house, we put in blinds. Now blinds are very ineffective at stopping any kind of residual heat transfer through the glass. So we've swapped those over for louvers, and those louvers are air gapped. They're the hollow louver panels, which also help to stop the any heat coming through the glass. All of the living areas have fans, and there are high ceilings throughout the house. That's obviously great for moving air around and just keeping the house at a fairly even temperature, because there's such a big thermal mass. And upstairs and downstairs there's about a 7 or 8 meter height range. So having the fans enables us to keep the air inside the house moving around if it's still outside, and moves sort of, you can either basically move heat up or heat down or cool up, as the case may be. And you can see there that we have split cycle air conditioning, and we find that if we run one split cycle air conditioner in a house which is sort of quite large, that's sufficient to keep the humidity out of the house and keep the whole house comfortable. We usually run that at about 24 to 25 degrees during summer, so it literally costs nothing to run. And here again is the house as a finished product. And you can see the pool solar blanket and 12.5 kilowatts or thereabouts of solar panels. The two round dots that you see on the roof are the mechanical extractors, which we run quite a lot of the time, especially in summer. But as I say, they literally cost nothing to run. So I guess my argument to say this is a sustainable house is pretty much that it's designed with solar orientation, airflow, thermal mass in mind. The energy costs that go into the house as a completed house are very little. However, the carbon offset, the carbon cost of building the house in the first instance is relatively high. The offset for that, as I said earlier, is that it will last for hopefully generations.